ਵਿਦਿਆਰਥੀਓ, ਅੱਜ ਦੀ ਕਲਾਸ ਵਿੱਚ ਤੁਹਾਡਾ ਸਵਾਗਤ ਹੈ। ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਆਪਾਂ ਜਲਦੀ ਨਾਲ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਨੂੰ ਸਮਝਾਂਗੇ ਅਤੇ ਨਾਲ ਹੀ ਅਸੀਂ ਇਸ ਤੇ ਬੇਸਡ ਕੁਝ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਸੋਲਵ ਕਰਾਂਗੇ। ਕੀ ਤੁਸੀਂ ਜਾਣਦੇ ਹੋ ਕਿ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਕੀ ਹੁੰਦੀ ਹੈ? Electric field due to a charge is the space around the charge in which any other charge is acted upon by an electrostatic force of repulsion or attraction. ਜੇ ਅਸੀਂ ਸਪੇਸ ਦੇ ਵਿੱਚ ਕਿਸੇ ਪੁਆਇੰਟ ਤੇ ਇੱਕ ਸੋਰਸ ਚਾਰਜ Q ਮੰਨੀਏ ਅਤੇ ਸੋਰਸ ਚਾਰਜ ਤੋਂ ਡਿਸਟੈਂਸ R ਤੇ negligibly small positive test charge Q0 ਰੱਖੀਏ ਤਾਂ ਉਸ ਫੀਲਡ ਪੁਆਇੰਟ ਤੇ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਇੰਟੈਂਸਿਟੀ E ਹੈ ਵੈਕਟਰ E equal to 1 upon 4 pi epsilon naught into Q upon R cube into vector R. Let us try some numerical problems on it. A water particle of mass 10.0 milligram and having a charge of 1.50 into 10 raised to the power minus 6 coulomb stays suspended in a room. You have to find out the magnitude of electric field in the room and the direction of the field. Here, mass of the particle m is 10 milligram, which is equal to 10 raised to the power minus 5 kg. And charge Q is equal to 1.50 into 10 raised to the power minus 6 coulomb. As the water drop stays suspended in the room, therefore, force F due to electric field must be balancing the weight of the drop. That is, F is equal to Q into E, or F is equal to mg. Hence, E would be equal to mg upon Q, that is 1 into 10 raised to the power minus 5 into 9.8 upon 1.50 into 10 raised to the power minus 6, which is equal to 98 upon 1.5, that is 65.3 Newton per coulomb. ਇੱਥੇ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਦੀ ਡਾਇਰੈਕਸ਼ਨ ਵਰਟੀਕਲੀ ਅਪਵਰਡਸ ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ ਤਾਂ ਕਿ ਫੀਲਡ ਦੇ ਕਾਰਨ ਅਪਵਰਡ ਫੋਰਸ weight ਨੂੰ ਬੈਲੈਂਸ ਕਰ ਸਕੇ। Our next problem is 2-point charges of 2 into 10 raised to the power minus 7 coulomb and 1.0 into 10 raised to the power minus 7 coulomb are 1 centimeter apart. Then, what is the magnitude of the electric field produced by either charge at the site of the other? Here, charge Q1 is 2.0 into 10 raised to the power minus 7 coulomb and charge Q2 is 1.0 into 10 raised to the power minus 7 coulomb and R is 1.0 centimeter or 1.0 into 10 raised to the power minus 2 meter. Then, the electric field at the site of a charge will be the electric field produced by the other charge. Therefore, electric field due to the charge Q1 at the site of Q2 would be E1 equal to 1 upon 4 pi epsilon naught into Q1 upon R square. This is equal to 9.0 into 10 raised to the power 9 into 2.0 into 10 raised to the power minus 7 upon square of 1.0 into 10 raised to the power minus 2. On calculation, we get E1 equal to 1.8 into 10 raised to the power 7 Newton per coulomb. Similarly, electric field due to the charge Q2 at the site of Q1 would be E2 equal to 1 upon 4 pi epsilon naught into Q2 upon R square. This is equal to 9.0 into 10 raised to the power 9 into 1.0 into 10 raised to the power minus 7 upon square of 1.0 into 10 raised to the power minus 2. On calculation, we get E2 equal to 9.0 into 10 raised to the power 6 Newton per coulomb. आओ ਹੁਣ एक ਹੋਰ प्रॉब्लम हल करिए. A pendulum bob of mass 80 milligram carrying a charge 2.0 into 10 raised to the power minus 8 coulomb is at rest in a horizontal uniform electric field 2 into 10 raised to the power 4 volt per meter. Here you have to find the tension in the thread of the pendulum and the angle it makes with the vertical. Let us consider that a pendulum bob of weight mg carrying a charge q is suspended in the electric field E such that it comes to rest at point A so that it makes an angle theta with the vertical. At point A, the bob is acted upon by these forces. First, weight mg vertically downward act कर रहा है. Second, string which tension T AS ते नाल है. Third, bob ते electrostatic force QE horizontal direction which है. Since the bob is in equilibrium under the action of these forces, if we resolve the tension force, we get T sin theta balancing the electrostatic force QE and T cos theta balancing the weight mg. On dividing, we get tan theta is equal to QE upon mg. On substituting the values of Q, E, M and G, we get tan theta equal to 2 into 10 raised to the power minus 8 into 2 into 10 raised to the power 4 upon 8 into 10 raised to the power minus 5 into 9.8. This gives tan theta equal to 0.5102 or theta is equal to 27.3 degree. Tension T can be calculated as T equal to QE upon sin theta, that is equal to 2 into 10 raised to the power minus 8 into 2 into 10 raised to the power 4 upon sin 27.3 degree. This gives T equal to 8.72 into 10 raised to the power minus 4 Newton. If there is no single charge but a group of discrete charges, then what would be electric field due to a discrete distribution of charges? The net electric field due to the discrete distribution of charges is equal to 1 upon 4 pi epsilon naught into summation of qi upon ri cube into vector ri with the value of I from 1 to n, where ri is the distance of field point from the ith charge. On the other hand, in terms of position vector, E becomes equal to 1 upon 4 pi epsilon naught into summation of qi upon cube of the magnitude of vector r minus vector ri into vector r minus vector ri with the value of I from 1 to n. Here, r is the position vector of field point and ri is the position vector of ith charge. आओ ग्रुप ऑफ चार्जेस ਦੇ ਕਾਰਨ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਤੇ ਬੇਸਡ ਕੁਝ ਨਿਊਮੈਰੀਕਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ. 2 point charges of 5.0 into 10 raised to the power minus 19 coulomb and 20.0 into 10 raised to the power minus 19 coulomb are separated by a distance 2 meter. You have to find the point on the line joining them at which electric field intensity is 0. Here, Q1 is plus 5 into 10 raised to the power minus 19 coulomb and Q2 is plus 20 into 10 raised to the power minus 19 coulomb and separation R is equal to 2 meter. Let us consider that the resultant electric field is 0 at point O on the line AB joining the two charges. Let AO be equal to X. Then BO would be equal to R minus X or 2 minus X. Let E1 and E2 be the electric fields at the point O due to the charges Q1 and Q2 respectively. Then electric field will be 0 at the point O only if E1 and E2 are equal in magnitude but opposite in direction. This means 1 upon 4 pi epsilon naught into Q1 upon AO square is equal to 1 upon 4 pi epsilon naught into Q2 upon BO square or Q1 upon X square is equal to Q2 upon square of 2 minus X, that is 5 into 10 raised to the power minus 19 upon X square equals to 20 into 10 raised to the power minus 19 upon square of 2 minus X or 4 into X square is equal to 2 minus X whole square, or we can get 2x equal to plus or minus of 2 minus x. This would give x either equal to 2 by 3 meter or minus 2 meter. Here, x equal to minus 2 meter is not a valid solution. Thus, electric intensity will be 0 at a distance of 2 by 3 meter from the charge Q1. Our next problem is 2 point charges Q1 and Q2 are of plus 5 microcoulomb and minus 6 microcoulomb respectively. These point charges are located 20 centimeter apart in vacuum. You have to find out the electric field at the midpoint of the line AB joining these two charges. If a negative test charge of magnitude 1.5 into 10 raised to the power minus 9 coulomb is placed at this point, then what would be the force experienced by the test charge? Here, Q1 is plus 5 microcoulomb or 5 into 10 raised to the power minus 6 coulomb, and Q2 is minus 6 microcoulomb, or minus 6 into 10 raised to the power minus 6 coulomb, and R is 20 centimeter, or 0.2 meter. Let O be the midpoint of the line AB, so that AO is equal to BO, which is equal to 0.1 meter. Therefore, electric field E1 at point O due to charge Q1 is 1 upon 4 pi epsilon naught into Q1 upon AO square, which is equal to 9 into 10 raised to the power 9 into 5 into 10 raised to the power minus 6 upon square of 0.1. On calculation, we get E1 equal to 4.5 into 10 raised to the power 6 Newton per coulomb along AB. Similarly, electric field E2 at point O due to charge Q2 is 1 upon 4 pi epsilon naught into Q2 upon BO square, which is equal to 9 into 10 raised to the power 9 into 6 into 10 raised to the power minus 6 upon square of 0.1. On calculating, we get E2 equal to 5.4 into 10 raised to the power 6 Newton per coulomb along AB. Since E1 and E2 both are in same direction, the net electric field at point O would be equal to the algebraic sum of E1 and E2. Hence, net field E would be 9.9 into 10 raised to the power 6 Newton per coulomb along OB. If a negative test charge Q0 of magnitude 1.5 into 10 raised to the power minus 9 coulomb is placed at this point, the force on the test charge would be equal to Q0 into E, that is, minus 1.5 into 10 raised to the power minus 9 into 9.9 into 10 raised to the power 6. This would give F equal to minus 1.485 into 10 raised to the power minus 2 Newton. Here, the negative sign shows that the direction of force is opposite of electric field E, that is, along BO. Dipole moment of an electric dipole. Vector P is equal to Q into vector 2A. Electric field intensity at a point on axial line of dipole E is equal to P upon 4 pi epsilon naught into 2R upon square of R square minus A square. Electric field intensity at a point on equatorial line of dipole E is equal to P upon 4 pi epsilon naught into 1 upon R square plus A square raised to the power 3 by 2. When an electric dipole is placed in a uniform external electric field of magnitude E at an angle theta with the direction of E, then the torque acting on the dipole vector tau is equal to the cross product of the vector P and vector E. Potential energy possessed by the dipole by virtue of its particular position in the electric field U is equal to minus dot product of the vector P and vector E. आओ इलेक्ट्रिक डाइपोल बारे कुछ न्यूमेरिकल प्रॉब्लम्स हल करिए. An electric dipole consists of a positive and negative charge of 4 microcoulomb each, placed at a distance of 5 millimeters. Can you calculate its dipole moment? Here, charges are 4 microcoulomb, that is 4 into 10 raised to the power minus 6 coulomb, and minus 4 microcoulomb, that is minus 4 into 10 raised to the power minus 6 coulomb respectively. And the dipole length 2a is equal to 5 into 10 raised to the power minus 3 meter. Therefore, dipole moment P, which is equal to 2a into q, would be equal to 5 into 10 raised to the power minus 3 into 4 into 10 raised to the power minus 6, that is 2 into 10 raised to the power minus 8 coulomb meter. चलो एक और प्रॉब्लम लेइए. Calculate the field due to an electric dipole of length 10 centimeter and consisting of charges of plus or minus 100 microcoulomb at a point 20 centimeter from each charge. First of all, let us draw a diagram. Here, we have to calculate electric field at a point along equatorial line, as field point is equidistant from both charges. Here, charge Q is 100 microcoulomb or 1 into 10 raised to the power minus 4 coulomb, and dipole length is 10 centimeter. Let P be the point at a distance of 20 centimeter from either charge. Under root r square plus a square is 20 centimeters or 0.2 meter. Since electric field intensity E at a point on equatorial line of dipole is equal to Q upon 4 pi epsilon naught into 2a upon r square plus a square raised to the power 3 by 2. Substituting the values, we get E is equal to 9 into 10 raised to the power 9 into 1 into 10 raised to the power minus 4 into 0.1 upon cube of 0.2, that is 9 by 8 into 10 raised to the power 7. This would give E equal to 1.125 into 10 raised to the power 7 Newton per coulomb. एक और प्रॉब्लम सॉल्व कर दे हाँ. An electric dipole consists of two charges of 0.1 microcoulomb separated by a distance of 2.0 centimeter. The dipole is placed in an external field of 5 into 10 raised to the power 5 Newton per coulomb. Here, you have to measure the maximum torque exerted by the field on the dipole. In this problem, charge Q is of 0.1 microcoulomb or 1 into 10 raised to the power minus 7 coulomb. Length of the dipole 2a is 2.0 centimeter or 0.02 meter, and The external electric field is 5 into 10 raised to the power 5 Newton per coulomb. We know that the maximum torque, tau, is equal to Pe sine 90 degree or Q into 2A into E sine 90 degree, which gives tau equal to 1 into 10 raised to the power minus 7 into 0.02 into 5 into 10 raised to the power 5 into 1. This gives tau equal to 1 into 10 raised to the power minus 3 Newton meter.
आओ हुण मैं तुहानू दसां कि इलैक्ट्रिक फ्लक्स की है। जे किसी इलैक्ट्रिक फील्ड के अंदर कोई सरफेस होवे तां इलैक्ट्रिक फ्लक्स सरफेस के नॉर्मल डायरैक्शन विच लंघ रहीआं इलैक्ट्रिक लाइन्स ऑफ फोर्स के कुल नंबर नू दर्शाउंदा है।
Electric flux through a surface held inside an electric field is the total number of electric lines of force crossing the surface in a direction normal to the surface. For the variation in the angle between area vector and electric field, flux varies as sinusoidal curve.
Total electric flux, capital Phi, through the closed surface is equal to the line integral over a closed curve of the dot product of electric field vector E and area vector ds. On the other hand, according to Gauss theorem, electric flux through a closed surface is equal to the ratio of enclosed charge Q and epsilon naught. Let us now try a numerical problem based on Gauss theorem.
An early model for an atom considered to have a positively charged point nucleus of charge Ze surrounded by a uniform density of negative charge up to a radius r. The atom as a whole is neutral. For this model, what is the electric field at a distance small r from the nucleus? The charge distribution for this atomic model is shown in the diagram. According to this, charge on nucleus is plus Ze. Since the atom is neutral, therefore, total negative charge should be minus Ze. Hence, the negative charge density rho would be charge per unit volume, which would be equal to minus Ze upon 4 by 3 pi r cube or minus 3 Ze upon 4 pi r cube. According to Gauss theorem in electrostatics, for a Gaussian spherical surface of radius small r, electric flux is equal to E into surface area 4 pi r square, which is also equal to ratio of enclosed charge Q and epsilon naught. When the field point is outside the atom, that is, small r is bigger than capital R, the enclosed charge is plus Ze and minus Ze, which is 0. Hence, electric field is also 0. But when point is inside the atom, that is, small r is smaller than capital R, the charge enclosed by Gaussian surface is plus Ze plus rho into 4 by 3 pi r cube, which is Ze minus Ze into r cube upon capital R Q. Therefore, electric field E is equal to Q upon 4 pi epsilon naught small r square, which is equal to ZE upon 4 pi epsilon naught into 1 by small r square minus small r by RQ.
ਇਸ ਦੇ ਨਾਲ ਹੀ ਅਸੀਂ ਅੱਜ ਦੇ ਪਾਠ ਦੀ ਸਮਾਪਤੀ ਕਰਦੇ ਹਾਂ। ਮੈਨੂੰ ਵਿਸ਼ਵਾਸ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ ਦਾ ਕਨਸੈਪਟ ਅੱਜ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਣਾ ਹੈ। ਧਿਆਨ ਦੇਣ ਲਈ ਸ਼ੁਕਰੀਆ। ਅਗਲੀ ਵਾਰ ਇੱਕ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਨਾਲ ਫਿਰ ਮਿਲਾਂਗੇ।